Okay, so we will be discussing purely ray diagrams today. And for that, we have to understand how different surfaces reflect light. Now, there's one and only one fundamental principle for reflection of light, and that is your angle of incidence is, so जो आपने law of reflection पढ़ा है, which is your angle of incidence, this is the surface, and then अगर हमारे पास incident light है. Now, just to make continuity, let's pick a color and stick to it. What color do you want for light rays? Just pick a color, dude. Just pick. Let's take yellow. It's seems logical. So, I mean, no, it's not. Doesn't seem logical. I mean, any color is equivalent here because light is light. Doesn't really have to follow color. But you can only make light a ray when you add these arrows. Now, if at this particular point I make a 90-degree, this is what we call as a normal. Now, this normal is like, matlab, you don't have to think of normal as a concept of specifically light. This is a mathematical concept. Any perpendicular, अगर कोई भी point है, उस point से tangent एक tangent बनेगा, एक normal बनेगा. अगर एक point है, तो उस point से हमेशा एक tangent बनेगा और उस tangent से perpendicular एक normal होगा. This particular line, and this doesn't have to have arrows. It can be a dotted line. This AB is what we call normal. ठीक है, this AB is what we call is normal, and this is surface. This is what we call as the what? Incident ray, and this is what we call as the reflected ray. Now, all of these rays and all of these normals are with respect to a particular point of contact, ठीक है, or point of, this is point of incidence. Remember, every time light reflects for a particular point of incidence, all these rays and angles will change. Can change. I mean, they might be same as well for some of them, but all of this will change as soon as the point of contact or point of incidence changes. Matlab, incident ray isn't supposed to hold true meaning of incidence कि वो मतलब किसी वो reflected ray भी हो सकती है जो incident बन सकती है अगर वो दोबारा reflect हो जाती है तो. So it's just with reference to a particular point of incidence. This angle between the normal and the incident ray is what we call angle of incidence, and the angle between your normal and reflected ray is what we call angle of reflection. Now we know that angle I is equals to angle R. Let me teach you a little bit extra. I want to ask the question why. Now, have you never wondered why? Why does it follow this? Why is it supposed to be equal? Why can't it be not equal? Why is it? I mean, why haven't you asked that question already from years of learning about light? That okay, the angle of incidence is equals to angle of reflection. Yes, I have a law, but light was supposed to be particles moving in straight lines. Why would they follow a mathematical law at all? There should be some reason, right? There should be some reason. Now, obviously, you don't know that. A lot of people do not know that. And one of the initial theories, and this is the only theory I am going to explain you, is light takes the path of minimum time. Now, to reach from point A to point B, let's say this is point A and this is point B. After reflection, अगर मुझे point A से point B जाना है, तो just take a look at the alternative path that it can take. So I'll be using a dotted line for alternative paths. So it can use this path. Okay, is it visible at all? It's not visible, right? I'll change color. I'll take alternative path. So this is one of the alternative paths. Okay, ये तो visible है ना? This is alternative path. Now you can also have this as an alternative path from A to B. Right? Turns out that of all these paths, the minimum time is on the path in which angle of incidence is equals to angle of reflection. And that is the reason light takes this path. No, that's a good point. Why, and this is again one of the scientists have worked on it, that why would light tend to minimize time? ठीक है, and that is a separate theory, difficult for right now for an explanation. But the reason for angle of incidence to be equal to angle of reflection in this particular case is because it takes the shortest possible time. Now the question arises, what about when it is about two different medium? If light is always following the minimum possible time, what about this particular diagram? Now again, I will not explain you the mathematics around it because it is things that you have not studied abhi tak. So let's just say we have two now medium and you have studied refraction of light, right? So आपने जब refraction of light पढ़ा था उसमें आपने पढ़ा था कि you have this sin I equal to let's say ये पॉइंट है A to B, ठीक है, A to B है ये पॉइंट्स, दिस इज योर अगेन पॉइंट ऑफ इंसिडेंस, and then here you have what we call a normal extending both sides because it is simply an imaginary line anyway. So A, oh sorry, PQ, let's say this is PQ, और सॉरी ये 11 तो यहाँ पे भी इसे PQ ले लो या A dash B dash ले लो, यहाँ भी A dash B dash ले लेते हैं. This is our normal. This is what we call as angle of incidence. This is what we call angle of refraction. And we just know one thing, that it just turns out, and this is also this is the sequence in which it was found out. It was not कि हमने पहले सीख लिया क्यों होता है and then we derived the formula. No, no, no. They just happen to be कि यहाँ पे ना जब मैं sin of angle I निकालता हूँ divide by sin of angle R करता हूँ, this just comes out to be a constant which is the refractive index and light follows this. Now, what the hell does it have to do anything with the shortest possible path of time? Turns out, again, because this is in two different mediums and the speed of light changes with respect to medium, that this particular constant is a function and this particular function is constant when we have this. पता है ना तुम्हें V2 by V1 भी होता है ना? मतलब पढ़ा होगा तुमने ये तो refractive index से. So turns out this is again of all the possible different paths that light could have taken from point A to point B, this particular path, this particular path. Yes, shortest, we are not talking about shortest distance. We are talking about minimum time. It doesn't matter if it is, for example, सोच के देखो, मुझे यहाँ से गुड़गांव जाना है, ठीक है, मुझे यहाँ से गुड़गांव जाना है, and let's just say कि there are multiple paths to go there, ठीक है, let's just say there are multiple paths, but ये आगे इधर वाली रोड ब्लॉक हो गई, कहते हैं ना, मतलब जैसे इधर जो MRIS यूनिवर्सिटी साइड वाली रोड है वो ब्लॉक हो गई, completely block. Now tell me, even if it is the shortest path to reach to Gurgaon, won't you reach like Jaldi when you go through Delhi? Obviously, because that road is blocked. Now the time it takes to unblock that road would be accounted for in your time. So we are talking about minimum possible time because that is what matters in the end, right? मतलब I don't care how short the path is. I don't care. For example, मुझे अभी अगर आरत तक पहुंचना है, what is the short टेबल पे चढ़ के चला जाऊं, ठीक है, which is the faster path, but if I move it around, no table, it's difficult to like move through tables and then a lot of different variables to account for. Not that it matters, but I can fall down, I'll have to significantly more energy to reach there, but in the same amount of energy or even less energy I can reach faster there, even though this is the shortest path. So displacement is the shortest path, doesn't have to be the fastest path, right? All of us know this. All of us know this. मतलब अगर हम गाड़ी भी चला रहे हैं, so it's not just about the shortest path. मतलब it's also about at what particular speed what will be better. ठीक है? हाँ, वही मैं कह रहा हूँ, मतलब oh yeah, you might think, मतलब it is distance wise you might think कि this might be a shorter, कहते हैं lesser time, this will take lesser time. Turns out, no. This is a mathematical equation. No, that's the thing. You cannot understand the mathematics behind it. So you'll have to take my word for it. And eventually, when you learn your functions and your what do you say, derivatives and minimizing functions, you will figure out that this is the shortest path. So yes, it's a minimum possible time that this takes. And it was again first initially this was found out, and eventually people figured out that yes, this analogy works. No, who said? I mean, no. It's not a simple equation. You have to understand there are two different mediums here. यहाँ पे two different mediums है. Speed change हो रही है एक point के बाद. जैसे हम लीनियर इक्वेशन में करते थे ना कि एक पर्टिकुलर पॉइंट तक हम गए, उसके बाद स्पीड चेंज हो गई ट्रेन की, तो फिर तो एवरेज स्पीड सीधा ऐसे नहीं निकलती थी ना. So yes, this is how it works. Now that we understand a little bit of dynamics upon ki how these both these phenomena are point phenomena. Point phenomena मतलब समझते हो कि एक जिस point पे angle of incidence होगा, जिस point पे incident होगा ना, उस point पे reflection follow होगा. Which means when we have let's say, because this is the one of the things which is pretty confusing for a lot of children, कि अगर it is only about flat surfaces, then अगर flat surface पे parallel beam of light आती है, let's say I make a parallel beam of light मतलब समझते हो ना, there are parallel rays of light in it. Okay, so let's say you have multiple light rays, and then ये multiple light rays जो है ये इस पे fall करती है surface पे, तो ये क्या होनी चाहिए, ये मल्टीपल लाइट रेज, इनके बीच में अगर जितने ऑल पॉसिबल पर्टिकुलर लाइट रेज, ऑल ऑफ देम शुड बी रिफ्लेक्टेड पैरेलली, है ना? सो विच मींस ऑल फ्लैट सर्फेसेस शुड हैव परफेक्ट रिफ्लेक्शन. ठीक है, परफेक्ट रिफ्लेक्शंस. बट turns out what we define flat in the real sense is not exactly flat on the molecular level, or if we magnify much, for example, all these tables that you have, the reason why they are non-reflecting, even though it seems pretty flat to us, is because actually scientifically they are not flat. They're actually not flat. What happens is they have, हाँ मतलब perfectly flat तो कुछ नहीं होता, ठीक है, but they have what we called like मतलब you think micro देख रहे हो ये सारे ऐसे एजेस है. So this is what your table would look like. So what happens is, now this is our table, and now what we do is, अब अगर हम एक पर्टिकुलर पॉइंट पे एंगल ऑफ रिफ्लेक्शन लगाएंगे, so now you'll have different rays, and different rays turning out differently depending on which point it strikes on the surface, because different points on the surface are at different levels. So this, it's never that this particular law of reflection never fails, मतलब ये हमेशा वर्क करेगा. It's just that it works on a rather fundamental level, which is at the point of incidence, and you'll have multiple normals, and depending on where the normal is, your angle of incidence and angle of reflection will always be the same. This particular is what we call diffused reflection. एंड दिस द रीजन कि ये इमेज फॉर्म नहीं कर पाता है, बिकॉज जो मेरी तरफ से लाइट रेज जा रही है, जो टेबल पे स्ट्राइक कर रही है, वो अलग अलग रैंडम डायरेक्शन में डिस्पर्स हो रही है, जिसकी वजह से इट इज नॉट एबल टू फॉर्म प्रॉपर इमेजेस. क्या डजंट मैटर, 2 मीट करने से इमेज नहीं बनती है. दैट्स द थिंग कि हाँ, वी विल करेक्ट इट. इट्स नॉट द करेक्टिंग, 2 लाइट रे मीट करने से इमेजेस कभी नहीं बनती है. इट्स एवरी सिंगल लाइट रे फ्रॉम दैट इमेज टू दैट, एंड ऑल्सो इन फोकस. you'll see blurry images when it is out of focus. तो जब आप डायग्राम्स बना रहे होते हो ना, जब आप रे डायग्राम्स बनाते हो, आप एग्जैक्टली इन फोकस इमेज की पोजीशन निकाल रहे होते हो. इमेज आउट ऑफ फोकस भी बन सकती है. ऐसा नहीं है कि एक जगह पे इमेज है, आगे गए तो गायब हो गई, पीछे गए तो गायब हो गई. नहीं, ऐसा नहीं होता. ऑफ फोकस होता है. हाँ, नहीं मतलब तब भी नहीं होता, वो ऑफ फोकस होता है बस. हाँ एग्जैक्टली, जैसे मायोपिया, मतलब इफ यू हैव अ मैग्नीफाइंग ग्लास तो उसमें भी देखोगे तुम, जस्ट एक्सपेरिमेंट विद मैग्नीफाइंग ग्लास, you'll notice कि it you can make it off focus and in focus, or just use a camera, it has lens system, right? It can be off focus and in focus, all of that works. Now that we understand it, let's do the first ray diagram for, or first note this down. This is your reflection, this is your refraction, this is your diffuse reflection. Just some of the things I wanted to discuss. Yeah, I'll give it, but I'll give it written down things. So you just need to practice drawing right now. Don't necessarily have to do anything else. Now let's see what happens through a plane mirror. Okay. So let's say we have a plane mirror. Khach, 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 khach. एक प्लेन मिरर है, एंड दो केस करते हैं. एक तो पॉइंट साइज ऑब्जेक्ट की बात करते हैं पहले. लेट्स से वी हैव अ पॉइंट साइज ऑब्जेक्ट. ये पॉइंट ए है, एंड देन इसकी इमेज बनानी है मुझे. अब ध्यान से देखना, देखो. Now the problem is, what a lot of people don't understand is, we just make extreme rays. We just make rays which are at extremes. Doesn't mean और rays नहीं होती, बहुत सारी rays होती है. हाँ मतलब, so यहाँ इस पॉइंट से जितनी भी रेज निकल रही है, ठीक है, वो पहली बात तो, अच्छा, लेट मी मेक इट प्रॉपरली. लेट्स से वी हैव दिस these two rays as फ्लैट सरफेस है, तो मेरे लिए एंगल ऑफ इंसिडेंस और एंगल ऑफ रिफ्लेक्शन बनाना बड़ा आसान है. व्हाट आई एम गोइंग टू डू इज कि दोनों पॉइंट्स पे नॉर्मल बना लेते हैं. सो नॉर्मल एट वन हेयर एंड नॉर्मल एट दिस पॉइंट. ओ, ये तो नॉर्मली फॉल कर रही है. नॉर्मली फॉल कर रही है तो रिट्रेस करेगी अपना पाथ है ना. और ये एंगल आई, और यहाँ पे भी हम एंगल आर उतना ही ले लेंगे, एंड देन दिस विल बी माय रिफ्लेक्टेड रे, राइट. So this will be my reflected ray. Now I can very much clearly see that these two rays do not meet each other, right? So these are diverging. If these two rays are diverging, I know कि ये इस side तो meet कर नहीं रही lines. Diverging है, तो opposite side meet करेंगी. So we just extend that in the opposite direction. और जब भी dotted lines बनाओ, make sure you never and never make arrows over them, because those are not rays. They do not exist. So ये देखो, अगर हम पीछे extend करें, and you can extend it further than, मतलब these are not rays, these are just reference lines. So this is what is the where we see the image A dash. Every single other point अगर मैं और बनाऊं, जैसे फॉर द कंफ्यूजन कि और कौन सी रेज हो सकती है सर, अरे यार रेज तो इनफाइनाइट हो सकती है. मान लो यहाँ से एक रे गई, वो ऐसे चली जाएगी, और ये भी पीछे जाके यही मीट करेगी. Okay, so you can have infinite such points, because there can be infinite such rays emerging out of this. All of them have angle of incidence is equals to angle of reflection, because obviously that is fundamental and that will work always. Okay, so these are the few rays. Now this is what we call the object. यहाँ पे मैंने point size object लिया है. This is what we call image. This distance is what is the image distance, and this distance is what we call object distance. Yes, in plane mirrors it is the same. This is, let's say, PQ is our mirror. This is the reflecting side. This is the what? Polished side. Okay. So yeah, you could think of this as the diagram for mm point size object. Reflection of light or image formation of a point size object in a plane mirror. ठीक है, ये बना लो. Then we'll do a some positive like side, let's say 2 centimeter, 3 centimeter or any, मतलब height होगी object की, इसके बाद उसे plot करेंगे. Also these objects will be, as we know, laterally inverted. Laterally inverted. What is the nature? Is this real or virtual? This is virtual, and virtual के साथ erect. ठीक है, it is the same size, but point size तो size matter नहीं करता. But yeah, it is the same size, virtual and erect, literally inverted at the same distance. ठीक है. So कभी कभी ऐसे questions भी आते हैं कि an object is moving towards the mirror at the speed of 2 km/h. तो how fast is his image moving towards him? 2 km/h. मतलब simple maths. Now let's say we have object of a given height. So we have one particular given height of object, and मुझे इसकी देखनी है कि image कैसे बनती है. Okay, now let's again have some rays. Let's have one of them as straight, and why? Yes, and another one at some particular angle. Let's say this is the angle. Similarly, ये दूसरे point से भी एक ये and एक ये 4 रेज बना दी मैंने. तो ये 4 रेज जा रही हैं. इस ऑब्जेक्ट से, 2 फ्रॉम द टॉप ऑफ द ऑब्जेक्ट एंड 2 फ्रॉम द बॉटम ऑफ द ऑब्जेक्ट। ठीक है, द टॉप वन, ये तो नॉर्मली फॉल कर रही है तो वापस आ जाएगी। दिस वन will have angle of incidence is equals to angle of reflection, so yeah, it will go somewhere here. Okay, I'm again approximating only. ये somewhere here. Okay, again तो ये वापस चले गए इधर, इधर। Now we make dotted lines for the top part. पहले top अलग अलग बनाएंगे दोनों के लिए। So top part के लिए if I start to make dotted lines, notice uh, I'm back tracing it. So again back tracing it means कि this would be my back trace for the top part and the other part. Similarly bottom part के लिए ये एक रे back trace कर दी हमने and दूसरी ये, and then यहाँ पे दोनों intersect कर रहे हैं। That is the place where my object lies. ठीक है, so this is the object, sorry, image lies. This is our object, this is our image, and even in this very simple diagram it is very much evident कि ये दोनों की height same होगी, h h dash और h o h I भी लिख सकते हो आप। This is u, this is v. Again this is a virtual image and direct image, and again यहाँ पे you can see कि मैंने सिर्फ टॉप और बॉटम की रेज बनाई है। doesn't really mean कि सिर्फ टॉप और बॉटम की रेज आएंगी। It can have multiple different rays moving through. For example, bottom से ये आई, चली गई, रिफ्लेक्ट हो गई, यहाँ पे आ गई, and as long as light can move through this particular, मतलब अगर मैं हाफ कवर कर दूं इसका, लेट्स से मैं इसका ना बॉटम हाफ कवर कर देता हूँ, इतनी दूर वाला पार्ट से कोई रिफ्लेक्शन नहीं होगी। इवन दो आधा पार्ट मैंने मिरर का कवर कर दिया, इमेज पूरी ही बनेगी, बस लाइट की इंटेंसिटी कम हो जाएगी। इंटेंसिटी का मतलब क्या होता है, कितनी ब्राइट है ना इमेज, वो कम हो जाएगी। पूरी की पूरी 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 मतलब पूरी इनफैक्ट इक्वली, मतलब इक्वली। एंड हाउ टू डिटरमाइन, क्या उसे हर एंगल पे ले जा रही है ये, यस, एंड इनफाइनाइटली मेनी रेज। बट देन अगेन अगर आप बॉटम पार्ट को कवर करते हो, डजंट मीन कि पूरी की इंटेंसिटी एग्जैक्टली सेम से कम होगी। Now that has a lot to do with geometry than exactly मतलब the exact chapter light, because light में rays geometry है। तो depending on कितने intersections हो रहे हैं of different rays और कितना एरिया आ रहा है जो बार बार illuminate हो रहा है और कितना पार्ट तुमने कवर करा है, intensity will change. So it's not कि मतलब अगर मैं कितना ही पार्ट कवर करूं intensity will remain same, it will change। ठीक है, it will change and different parts। तो ये तुमने देखा भी होगा कि मतलब अगर हम कभी let's say you are in a dark room and then एक जगह से लाइट आ रही है and then you cover half of it and everything is still visible, but some parts of some things are more visible than other parts of the same things, which means कि आपके पास different levels of illumination within the object भी हो सकता है अगर आप intensity के साथ खेल रहे हो। but overall image पूरी ही बनेगी, ऑब्जेक्ट आधा नहीं कट जाएगा। ऑब्जेक्ट आधा सिर्फ और सिर्फ एक केस में कटता है, जब सोर्स से लाइट नहीं आ रही होती, इसको मैं आधा कवर कर दूं, ऑब्जेक्ट को ही आधा कवर कर दूं मैं, जिससे ऑब्जेक्ट तक लाइट पहुंच ही नहीं पा रही। मतलब रादर देन कवरिंग द मिरर व्हाट आई डिड इज कि ऑब्जेक्ट से ना इस डायरेक्शन से इल्यूमिनेट था, यहाँ पे लैंप था, तो ये सारी जो लाइट आ रही है ना ऑब्जेक्ट से, वो इस सोर्स से आ रही थी, मैंने इसके आगे एक शैडो लगा दिया, तो अब ऑब्जेक्ट नहीं दिखेगा। यू हैव टू रियलाइज कि अगर ऑब्जेक्ट से लाइट एमिट हो रही है और वो किसी ना किसी तरीके से दूसरी साइड पहुंच जाती है, इवन ये रे, ठीक है, ये रे, ये सारी यहाँ तक पहुंच जाएंगी। So you don't have to think that much about it. Okay, we just make extremes. You don't have to make all of the rays, we just make extremes कि हमें border मिल जाए ऑब्जेक्ट का, हमें पता है बीच में भी साइड रेस आएंगी आएंगी। नहीं नहीं, अभी वो भी समझा दूंगा मैं, डोंट वरी। आप कभी भी, a lot of people think कि हम जब वो रे डायग्राम्स बना रहे होते हैं फॉर कॉनकेव लेंस और कॉन्वेक्स लेंस और कॉनकेव मिरर कॉन्वेक्स मिरर तो सिर्फ हम टॉप पार्ट बनाते हैं. Well, not really. We have a bottom part. We just don't ever think about it. Principal axis, but उस पे arrow बनाने होते हैं फिर. अगर तुम उस पे, हाँ वही तुम नहीं बना रहे हो ना, वही तो मैं कह रहा हूँ. तुम arrows बना नहीं रहे हो ना उस पे, which means कि तुमने नीचे वाले bottom नहीं बताया उसका कहाँ पे. But we are just assuming कि it is standing on top of the principal axis. So yes, you are taking the bottom rays as well. बोलो. Now let's discuss a little bit about spherical mirrors. Now that we have studied about your plane mirrors, we can discuss a little bit about spherical mirrors. Yes, mirrors can be actually any reflecting surface. So any random shape, you polish it enough, you get a mirror out of it, and different kinds of mirror are used in different particular like things. For example, currently the way in the same phenomena of mirrors is like the same phenomena, kind of similar light phenomena is for refraction, and when you study about lens. But currently you use progressive lens. No matter, people don't really use now purely concave or purely convex or bifocal lens. They just use progressive lens, and sometimes only a part of your eyes are defective, or in a particular angle it is not able to see properly, and all of that is fixed through, I mean, the way for example, you know about eye defects apart from myopia and hypermetropia. For example, cylindrical vision. Ha, exactly. So I mean, there are a lot of defects of vision and a lot of optical defects. I mean, when we say optical defects, we mean things that could be corrected due to purely just the refractive side of it. I mean, मतलब अगर मैं आईज में लेंस चेंज कर दूं या फिर उसके आगे कोई डिफरेंट टाइप का लेंस लगा दूं तो फिक्स हो पाए. All the other problems related to eyes, which is problems with the retina, problems with your optic nerve and stuff, they really cannot fix that. We really cannot fix that. Yeah. Oh, well, I mean, sometimes, yeah, sometimes it is a combination of different things. No. I mean, you cannot perceive it. Perspective problem की तरह सोच सकते हो उसको. Actually, the thing is, it's more like a now this discussion is out of the physics purview and more into medical science right now. So that's why I don't want to discuss it too much, because it is more of a medical thing to understand what causes what phenomena, what defect of eye is caused by what muscles, and what defect of eye is fixed through in different ways. So for example, even though when we say optical phenomena, even the ciliary muscles getting weaker is actually not really optical by the nature of it, but it can be corrected through optical means. That is what I'm saying. कि मतलब उसमें हम अगर हमारे इनफ कॉन्ट्रैक्ट रिलैक्स नहीं कर पा रहे तो हम उसे लेंस दे रहे हैं कि वो उसको हेल्प कर पाए. So just because sometimes things can be fixed optically doesn't mean their underlying cause was the optics of the eyes initially. Maybe it was initially a healthy eye, eventually it got to that point, which is true for everyone having weaker eyes when they grow old. ठीक है, which is true for everyone having their मतलब glasses put on after a certain age, कि मतलब इतना फोन में घुसे रहते थे कि आंखें खराब हो गई. ठीक है, which is true for a lot of you. So yeah, those are phenomena that are after a particular point of time but fixed through optics. Yeah. Now, when we talk about a spherical lens, and this is not a circle, this is a sphere. You have to understand this is a sphere, this is not a circle. We can just depict spheres through circles in 2D. That's why I'm making this. And the sphere will have a center. The reason a spherical lens is spherical mirror is called a spherical mirror because it is part of a sphere. Simple as that. Matlab, it is part of a sphere. That's why this is not an arc. This particular thing, अगर मैं यहाँ से यहाँ तक बनाऊं, this is not an arc. It is part of a sphere, or more you can call this a curvature. ठीक है, you can call this a curvature, not a curve. ठीक है. So now this will have a center, okay, and it will have a focus. Now we can actually mathematically prove that anything parallel to this particular line. Why would it? Let me just yeah, that's a common doubt. It's pretty common doubt. Okay, let's make a parallel. uh I mean, मैं इस साइड मिरर बना रहा हूँ, ये दिस इज द मिरर, आई एम मेकिंग अ कॉनकेव मिरर मतलब इधर बनाना पड़ेगा मुझे. सो दिस इज द ओनली पार्ट ऑफ मिरर. मैंने सिर्फ इतना पॉलिश करा है और पूरा हॉलो स्फेयर है. ठीक है, सिर्फ इस साइड मैंने रिफ्लेक्टिव कोटिंग कर दी जिससे रिफ्लेक्शन हो पाए. So this is our reflective coating. Now you get a ray of light. Let's say the point is key. Yes, obviously not all. Also, if when you even think about reflecting surfaces and transparency, nothing is 100% transparent. And if something is 100% transparent in air, it will be invisible in air. नहीं नहीं नहीं, रिफ्रैक्ट भी होगी, रिफ्लेक्ट भी होगी, सब कुछ होगा. तब भी होगा. अगर हर साइड से पेंट करिए तो लाइट अंदर नहीं जा पा रही उसके. सिंपल एज दैट. क्या? Yeah, and a lot of times it's the metals that do not absorb light. So for example, this is on a more fundamental level. On a more fundamental level, everything can be transparent. I'll be very very honest with you. Everything can be made transparent अगर हम enough frequency की light use करें and enough amplitude की. So it's just that though that light won't be visible to us. So what transparency in general sense means, a lot of assumption. First, we are talking about humans and the visible spectra of humans. Visible spectra of humans में जो rays जाती है, उसमें से क्या उसके पार्टिकल इतने बड़े हैं कि पास थ्रू नहीं कर पाए और अब्सॉर्ब कर ले. वरना तुम्हें पता है ना कि मतलब स्पेस तो बहुत होता है खाली खाली. तो ऐसा तो कोई फिजिकल बैरियर नहीं है, मैंने तो बहुत बार समझाया है. बिटवीन थिंग्स नॉट टचिंग एंड नॉट पासिंग थ्रू इट इज फोर्सेस, and forces that govern is not a physical barrier like wall. Do not understand your hand does not pass through your hand because of the fact कि इन दोनों के बीच में कोई physical barrier है. They just repel. No, again, in a force is not the problem here. You have to, याद है हम एक बार डिस्कस कर रहे थे कि देयर समथिंग, अगर सोच के देखो ना, चार चीजें हैं ऐसे, बहुत दूर दूर है. ठीक है. अब और चार और चीजें लाया तुम, ये भी बहुत दूर दूर है. ठीक है. बट इस ये तो तब है ना जब ये सिंगल लेयर है. हाउ मेनी लेयर्स इज दिस? बिलियंस ऑफ लेयर्स. बिलियंस ऑफ लेयर्स. Obviously things will interact. All of these repulsive forces. All of these repulsive forces. It's not that simple. It's not. तो yes, enough force है तभी तो hand shatter होके मतलब haven't you seen accidents? No, it will not. How do you think that this will be stay intact if something pass through it? It will not. It will interact. Yes, pressure definitely. Yeah, exactly. मतलब it will shatter it. It will shatter it. And this is where you're talking about bigger things. I'm even talking about very very fine things. When it interacts with things, it can pass through it. For example, if at all you can make like micro needles, बहुत छोटे, micro तो फिर भी बहुत ज्यादा है. Let's say you make nanometers से भी आधे के आधे 0.001 nanometers needles, and you press all of them through your hand. If it is thin enough, nothing will happen to your hand, and it might rupture more fundamental things. Let's say you have something that small that can rupture DNAs. It will give you cancer rather than bleeding. How interesting is that? But yeah, theoretically possible. Just imagine कि मेरे को ना कांटा चुभ गया पेड़ से और मेरे को कैंसर हो गया. Like what the hell? How does we bleed? No, but theoretically possible. Physically, no material can be that thin. क्यों नहीं होगा? म्यूटेट कर दिया ओ. नहीं होता रहता है, बट फंडामेंटली डीएनए ब्रेक करना इतने सारे साथ में पता है कितना डेंजरस होता है. रेडिएशन से यही होता है. रेडिएशन से यही होता है, दैट इंक्रीजेस द चांसेस ऑफ कैंसर अगेन. नो नो नो, इट्स वेरी डिफरेंट. वो तो बस एक नहीं नहीं, वो तो उल्टा काम कर रही है, वो तो उल्टा काम कर रही है, वो इतने बड़े पार्टिकल्स तेरे स्किन में छोड़ रही है, इतने बड़े बड़े पार्टिकल्स, जिसको ना जनरली इम्यून सिस्टम पता है क्या करता है आपका, सब कुछ डिसॉल्व कर लेता है। जो भी उसको एक्स्ट्रा टॉक्सिन्स मिलते हैं फालतू के, कि हम तो कुछ भी खा लेते हैं ना, इतने टॉक्सिक टॉक्सिक चीजें खा लेते हैं। वन ऑफ दीज डेज यू माइट हैव ईटन समथिंग वेरी वेरी टॉक्सिक, कि मतलब, बट हाउ डज इट गेट रिड ऑफ इट? वेल, इट गेट रिड्स ऑफ इट जस्ट बाय ईटिंग इट, एंड देन जस्ट गेटिंग एक्सीटेड और समथिंग। वो इतने बड़े होते हैं, वो खा ही नहीं पाता। तो व्हाट योर इम्यून सिस्टम डज, इट्स वेरी इंटेलिजेंटली, कि देखो उसको खा तो नहीं सकता, तो उसके अकाउंट बैरियर बना लेते हैं। सो दैट टैट यू सी इज द इम्यून सिस्टम मेकिंग बैरियर अराउंड इट, कि आइसोलेट करो इस जगह को। या आई डिड सेंड यू वन ऑफ दीस डेज, या इट्स एन इंटरेस्टिंग फिनोमेना, because one of these days the immune systems will get recycled. Some of the toxins will break down. No, हमें हटेगा कभी नहीं, but it will fade a little, because some of the toxins will fade. हाँ मतलब थिंग इज कि थोड़ा तो तोड़ सकता है ना, इम्यून सिस्टम इज वर्किंग रियली रियली हार्ड, सो इट विल ब्रेक अ लिटिल। एनीवेज, कमिंग बैक टू माय पॉइंट, व्हेन वी कम अ पैरेलल रे, नाउ ये देखो ये दोनों पैरेलल है, ठीक है? अगर ये दोनों पैरेलल है, व्हाट कैन आई से अबाउट दिस पर्टिकुलर एंगल? इस कॉर्ड को देखो, इज दिस, लेट्स टॉक अबाउट दिस एंगल, इज दिस अ पॉजिटिव और अ, मतलब जीरो, इज दिस अ पॉजिटिव एंगल, यस और नो? This is a positive angle. And at this point, I can make a tangent, tangent perpendicular to radius, हमने circles पढ़ रखी है। Now, is this falling normally? No, this is not falling normally. If this is not falling normally, अगर ये normally fall नहीं कर रहा है, तो ये exact same angle बनाएगा, right? So जो angle यहाँ पे angle of incidence, ये same angle यहाँ पे ही बनाएगा, angle of reflection। ठीक है, अब ध्यान से देखना, I'll just prove you something very very interesting. So let's just say this angle is, क्या लूं मैं इसको, थीटा लेता हूं, तो ये एंगल भी क्या आ गया, थीटा आ गया। ठीक है, अब ये रेडियस है, ठीक है, ये पूरा एंगल रेडियस है, ये पूरा रेडियस है, ये भी क्या है, रेडियस है। ठीक है, नाउ आई एम टॉकिंग अबाउट, थिंक अबाउट दिस पर्टिकुलर साइड, ये थीटा है, ये थीटा है, ओके, एंड दिस पर्टिकुलर होल साइड, अगर मैं यहां से देखो, I'll just prove you. Do you want to do this similarity wise? You can do it. I mean, just saying. कि ये, again, you can try and prove this. I don't have enough time to explain you perfectly. But when you do similarity in these two triangles, make a perpendicular, make a, and इन दोनों triangles को similar कर दो, इसको perpendicular बना के, ये देखो, ये perpendicular बनाएगी, ये वाला triangle, and then ये perpendicular बनाएगी, ये वाला triangle. And उसके बाद you can either use trigonometry or use Pythagoras to prove that this is half of radius, which is exactly what focus is. Half of the center of curvature, सेंटर ऑफ कर्वेचर तो पॉइंट है, रेडियस ऑफ कर्वेचर का आधा फोकस होता है, ठीक है, सो फोकल लेंथ होता है। So yeah, that all is, this is mathematics, all of this is circles that you have studied. So yes, this is, I mean, I don't see why it is so different, and this is the reason your course structure has circles and light in the same year. They thought about it, don't think they didn't think about it. We'll continue this.